Today we are going to discuss some geometrical figures called Centroid, Circumcenter C, Orthocenter O, Incenter I, Excenters I1, I2, I3, and very important one is 9-point center of a triangle. These terms are very important for the students to learn to understand geometry very clearly. Shall we discuss all these terms in detail? Coming to the first one, centroid. Centroid of a triangle is the point of intersection of all medians in a triangle is called centroid. The question arises again. What is meant by median? Median is a line or line segment which is joining from a vertex to the midpoint of opposite side in a triangle is called median. You will have three medians and these three medians will meet at a point called centroid. Once again I am going to say centroid is the point of intersection of all the three medians of a triangle is called centroid. If you have three vertices, see the first vertex is A and second one is B and third one is C, and D is the midpoint of the side BC. So median means it will bisect. Bisect means it will divide, it will cut the side into two equal parts, and that's why I am giving same symbol to these parts, means the length of these two parts is equal. Similarly, this is BE is second median and it is dividing the side AC into two equal halves, and the third one is CF, this is dividing side AB into two equal halves. And coming to the properties of this centroid, if you have three vertices, vertex is also a point. If their coordinates are x1, y1, here you may have x1, y1, and the coordinates of this vertex is x2, y2, and coordinates of this third vertex is x3, y3. Then you may find the centroid G by using the formula x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. If you observe, G is also a point. It will have x and y coordinates. If you want to get x coordinate, you have to do a summation of all the x coordinates of three vertices and divide the sum with 3. Similarly, if you want to get the y coordinate of the centroid G, then do the summation of all y coordinates of all three vertices, then divide with the 3. Then you will get this x coordinate and y coordinate whose point is G. And if you come to the second point, G, the point G divides every median in the ratio of 2:1 internally. That means this point G divides this median in the ratio of 2:1. That means this length is two parts, this length is one part. Similarly, from here this median have two equal parts up to this point and then the third part. In the similar way, it divides third median also in the ratio of 2:1. If we want to find G when you have the coordinates of A and D, it will be very easy by using sectional formula. And the third is most important point. It says that the centroid G is always inside the triangle, whatever the type of triangle may be. It may be acute, obtuse or right angle triangle. Coming to the second center of the triangle, it is very important, that is circumcenter. Circumcenter of a triangle is point of intersection of three perpendicular bisectors is called circumcenter and it is denoted with the letter C. Question arises, what are meant by perpendicular bisector? The name itself says that perpendicular means that will be perpendicular to the side, and bisector along with perpendicular, it will divide the side into two equal halves. That is said to be a perpendicular bisector. If you come to this example, this is one perpendicular bisector and it is bisecting the side BC at a point D, and if you observe, this part is the length of this one and this one are equal, and also it is perpendicular to the side BC at point D. Similarly, you have another perpendicular bisector and it is meeting the side AC at E, and you have third one, that is it is bisecting and having perpendicular to the side AB at point F. If you observe, these three perpendicular bisectors are meeting at a point called C. This point of intersection is called circumcenter of the triangle. And if you come to the properties of circumcenter, see, when they have given you the angle A, angle B and angle C along with vertices x1 comma y1, and here you may have x2 comma y2 and third one is x3 comma y3. If they have given you the angle A, angle B, angle C along with vertices x1 y1, x2 y2 and x3 y3, then you can calculate the circumcenter. See, circumcenter is also a point. It will have two coordinates, x coordinate and y coordinate. How you will calculate x coordinate? x1 sin 2a plus x2 sin 2b plus x3 sin 2c. Here sin 2c by sin 2a plus sin 2b plus sin 2c. Similarly, if you want to get the y coordinate of circumcenter, y1 into sin 2a plus y2 into sin 2b plus y3 into sin 2c by sin 2a plus sin 2b plus sin 2c. It is very easy to remember, sin 2a sin 2b sin 2c, and in the denominator we have to write sin 2a plus sin 2b plus sin 2c for both x coordinate and y coordinate. And coming to the second important property, that is this circumcenter may be inside the triangle, it may be outside the triangle, or it may be on the triangle. For acute angle triangle, the circumcenter will be inside the circle. For obtuse angle triangle, the circumcenter will be outside the triangle, and for right angle triangle, it will lie on the hypotenuse of the triangle. Coming to the third center of triangle, that is orthocenter O. See, orthocenter is also point of intersection of all three altitudes of a triangle is called orthocenter. It's very simple. Question arises, what is meant by altitude? So altitude is a line or line segment drawn onto a side which is perpendicular to the side, but it may or may not bisect the side into two equal halves. In the previous definition, that is perpendicular bisector, but here only perpendicular, and it may or may not bisect the side. That's why I didn't represented these two parts with same symbol. So this will be only perpendicular. This is the one altitude which is perpendicular to the side BC. If you see, this is another altitude which is perpendicular to the side AC, and the third is meeting the side AB at point F. It is perpendicular, but it will not bisect the side into two equal halves. That is called the point of intersection of all the three altitudes is called orthocenter, and this orthocenter is generally denoted with the letter O. Coming to the properties, if they have given the angle A, angle B, angle C along with their vertices, let their vertices be x1 comma y1 and x2 comma y2, then x3 comma y3. If they have given the vertices on angles A, B, C, then you may calculate orthocenter. Orthocenter is also a point. It will have x coordinate and y coordinate. X coordinate of orthocenter can be calculated using x1 into tan A plus x2 into tan B plus x3 into tan C by tan A plus tan B plus tan C, comma y1 into tan A plus y2 into tan B plus y3 into tan C by tan A plus tan B plus tan C. Generally, when you are finding the angle, you will use tan theta, and also for perpendicularity, generally we will use tan. That's why keep in your mind, when coming orthocenter, you have to use tan. And similarly, this orthocenter may be inside the triangle or outside the triangle, or it may be on the triangle, depending on the type of triangle you are having. So this is main important points about orthocenter. If you see the third center of the triangle, incenter, the point of intersection of angular bisectors of a triangle is called incenter. Now question arises, what is meant by angular bisector? The name itself says that angular means angle, bisect means into two equal parts. The line or line segment which is making the given angle into two equal halves, that is called angular bisector. If you observe, they have given angle A and this is angle, total angle A, and this line segment or line dividing the angle into two equal halves. That's why this is called angular bisector. You may have the second angular bisector of the angle B. It is dividing the angle into two equal halves. That's why I am representing the two halves with the same symbol. Similarly, you may have the third angular bisector and it is dividing into two equal halves. All these three angular bisectors meet at a point, and that point is called incenter of the triangle. So when you have given the vertices A, B, C, and if the coordinates of A are x1, y1 and the coordinates of B are x2, y2 and C are x3, y3, and the lengths of the sides are given. See, this is the length of the side BC and this is the length of the side AC and this is the length of the side AB. Generally, we will denote length of the side with small a, which is opposite to angle A. This is capital letter angle A, and we have to represent the length of the side opposite to the angle A with small a. Similarly, the length of the side which is opposite to angle B with small b. Similarly, small c. If they have given the lengths of the sides and vertices of and coordinates of the vertices, then you may calculate I as ax1 plus bx2 plus cx3 by a plus b plus c. And if you want to calculate the y coordinate of the incenter, a y1 plus b y2 plus c y3 by a plus b plus c. And the next point important is it is always inside the triangle. If you see the next center of the triangle, that is excenter. Excenter is also a point which is point of intersection of one internal angular bisectors and two external angular bisectors. This one internal angular bisector and the two external angular bisectors, and they will meet at a point called I1, that is called excenter of the triangle. See, if you observe, the angle A is there. I am drawing one angular bisector opposite to the side BC, and if you extend the side AB in this way, you will have one external angle here, and if you draw angular bisector here, we will have one angular bisector, and if you extend the side AC like this, you will have another external angle, and for that also I am drawing one angular bisector. And these three, one internal angular bisector, two external angular bisectors, they will meet at a point called excenter of the triangle. I am representing it with I1. Why? Because for every triangle there are three excenters. Why? Because I am drawing the excenter opposite to the angle A. You may draw the excenter which is opposite to the internal angle B in this way, and the third one may be opposite to the internal angle C. In this manner, you may have three excenters. You may name them as I1, I2 and I3. So when you coming into the property, for every triangle there will be three excenters. You may name them as I1, I2 and I3. See, if you want to calculate the excenter, you have the lengths of the three sides and the coordinates of three vertices. If you assume the coordinates of A x1 y1, B x2 y2, C x3 y3, and the lengths of three sides A, and this is B, small a, small b and small c, then you may calculate the incenter which is opposite to the internal angle A. See, I1 is equals to AX1 minus BX2 minus CX3 by A minus B minus C, comma AY1 minus, see, this is BY2 and this is CY3 by A minus B minus C, and you may calculate I2 and I3 also. For I2 you will have minus for AX1 and CX3, you will have plus for BX2, and if you want to calculate I3, you will have plus for CX3 and minus for AX1 and BX2. Finally, you are going to discuss very important center of a triangle, that is called 9-point center, and generally it is denoted as capital N. Very simple. See, in the triangle ABC, you will have three points called D, E, F, which are midpoints of the sides. See, DE is the midpoint of side BC, and E is the midpoint of side AC, and F is the midpoint of side AB. Similarly, G, H, I. G is the perpendicular to the side BC, H is the perpendicular to the side AC, and I is the perpendicular side AB. And another three set of points are there, that is J, K, L. J is the midpoint of the orthocenter O and the angular point A. See, this is angular point, this is orthocenter. For these 2 points, you may have one midpoint, let it be J. And similarly, you will have another midpoint of the angular point B and another orthocenter O here. Similarly, you will have L. See, you have now 9 points. If you draw a circle through all these points, if you draw a circle, the circle will touch all these 9 points. That circle is called 9-point circle, and the center of the circle is called 9-point center. See, you have 9 points D, E, F, G, H, I, J, K, L. The first set of 3 points are midpoints of the sides. The second set of points are called perpendiculars to the sides of the triangle, and the third set of 3 points are called midpoints of angular point and orthocenter. So If you draw a circle, the circle will touch all these 9 points, and that circle is called 9-point circle, and center of the circle is called 9-point center of the triangle. So in this way you may have the definition of 9-point center. I hope this video is helpful to everybody, and if you like my video, kindly subscribe my channel and don't forget to press the bell icon to receive more notifications. I will meet in the next more important video, and then have a nice day. Until then, thank you very much.